The problem with this hypothesis is that during the development of insulin resistance, it appears that the adipose tissue is one of, if not the first tissues to become resistant to insulin. All tissues with insulin receptors can become more or less insulin sensitive. Tissues that are less insulin sensitive are characterized as being more insulin resistant. All tissues with insulin receptors can become insulin resistant, but specific tissues appear to become resistant to insulin in different orders, to differing degrees, and it also depends on the stimuli being imposed. What I mean by this is not all tissues are equally insulin resistant, and things that drive insulin resistance, such as obesity, physical inactivity, and inflammation, affect different tissues to different degrees. As discussed in videos in the past, it is the oversupply and overabundance of lipids or fat inside of a cell that disrupts insulin signaling and leads to insulin resistance. For a fun graphic, fat accumulates inside the cell and can subsequently disrupt the insulin receptor, leading to what we would refer to as insulin resistance. Because adipose tissue is the primary storage site for fat in the human body, it is not until the adipose tissue gets so overstuffed that it can no longer store more fat that fat begins to be stored in organs and within the skeletal muscle, which would induce insulin resistance in these tissues. But as the adipose tissue becomes insulin resistant, it has an increase in lipolysis, which is the release of fat, and an inability to store further fat, which leads to what we refer to as ectopic lipid storage, or the storage of fat in places such as the liver, skeletal muscle, heart, pancreas, and even the reproductive organs. Therefore, it appears that obesity-induced insulin resistance throughout the entire body begins within the fat cells, as they become so overstuffed that they can no longer accommodate any more fat safely, and the fat that is currently inside of the cell inhibits the insulin signaling process, and we would refer to this tissue as being insulin resistant. That is when fat begins to be stored in the organs and muscles, which too induces these tissues to become insulin resistant. With that being said, we can cause insulin resistance specifically in the skeletal muscle through physical inactivity and the acute overconsumption of calories, specifically saturated fat. This is because it dysregulates the amount of lipid being delivered to skeletal muscle and the amount that is actually being expended, leading to an accumulation of fat within the skeletal muscle, which we would refer to as insulin resistance. Therefore, the insulin resistance associated with physical inactivity may actually begin in the muscles rather than the fat tissue, which may be particularly aggravating, as it means the muscles begin to dysfunction, but the adipose tissue is particularly sensitive to continuing to uptake fatty acids out of the bloodstream. In relation to acute overfeeding, it appears that excessive delivery of fatty acids to the skeletal muscle can induce acute skeletal muscle insulin resistance. And if we excessively consume saturated fatty acids in a caloric surplus, because they induce the greatest degree of liver fat storage, they appear in the short term to be the most deleterious to insulin sensitivity within the liver, which can be particularly dangerous because insulin resistance within the liver can raise blood glucose and is one of the most important driving factors for diabetes and its related complications. And finally, you may remember that inflammation can also induce insulin resistance, also by inhibiting the insulin receptor, similar to overfeeding and physical inactivity. When this inflammation is coming from the fat cells in a scenario of obesity, this can induce local insulin resistance within the fat tissue. But in response to some sort of other inflammatory insult, such as sickness, injury, or even a tooth infection, this insulin resistance can become systemic and have an effect on other tissues such as the muscles and even the organs. In all honesty, there is no perfect message to end this video with, but it's quite fascinating to understand the order of operations of insulin resistance and the way that different external and internal stimuli can affect the sensitivity of insulin at distinct tissues within the body.